What if I told you that for roughly 300,000 years, the entire universe was literally invisible? Not dark, not dim, but completely and utterly opaque. Today, we're diving into what scientists call the most confusing moment in cosmic history, and trust me, it's going to blow your mind. Picture this: you're trying to look through a thick fog so dense that you can't see your hand in front of your face. Now multiply that by infinity and stretch it across the entire universe. That's exactly what happened during what astronomers call the Dark Ages, and it might just be the most baffling period our cosmos has ever experienced. But here's where it gets really weird. This wasn't just any ordinary darkness. This was a time when light itself was trapped, when photons couldn't travel more than a few feet before getting absorbed, and when the universe was simultaneously the hottest and most confused it had ever been. And the craziest part? We're still trying to figure out exactly what happened during those mysterious 300,000 years. Let me take you back to the very beginning. About 13.8 billion years ago, our universe exploded into existence with the Big Bang. But contrary to what most people think, the Big Bang wasn't actually an explosion in space, it was an explosion of space itself. In the first fraction of a second, the universe expanded faster than light, creating the foundation for everything we see today. For the first few minutes after the Big Bang, the universe was like a cosmic soup of subatomic particles. Protons, neutrons, and electrons were flying around in a chaotic dance, and the temperature was so incredibly hot that these particles couldn't even stick together to form atoms. We're talking about temperatures of over 10 billion degrees Celsius. That's 600 times hotter than the core of our Sun. But here's where our story takes a fascinating turn. As the universe continued to expand, it began to cool down. And when the temperature dropped to about 3000 degrees Celsius, something incredible happened. For the first time in cosmic history, electrons were finally cool enough to be captured by protons and form the very first atoms, mostly hydrogen and helium. This moment is called recombination, and it's when our confusing period truly begins. You see, before recombination, the universe was filled with free electrons that were constantly scattering photons in every direction. It was like trying to drive through a snowstorm where every snowflake is made of pure energy. Light couldn't travel anywhere without immediately bumping into an electron and getting knocked off course. But when recombination happened, something magical occurred. Suddenly, most of those free electrons were locked up inside atoms, and for the first time ever, photons could travel freely through space. The universe became transparent almost instantly. This is the light we still see today as the cosmic microwave background radiation, the afterglow of the Big Bang itself. Now here's what makes this period so confusing and fascinating. During those 300,000 years between the Big Bang and recombination, the universe was in a state that's almost impossible for us to imagine. It was incredibly hot, incredibly dense, and completely opaque. But it was also perfectly smooth, with tiny quantum fluctuations that were so small they were practically invisible. Think about it this way. If you could somehow survive in that early universe, you wouldn't see stars, galaxies, or any of the structures we observe today. You wouldn't see anything at all because light couldn't travel. You'd be surrounded by a glowing plasma that was simultaneously everywhere and nowhere, bright beyond imagination yet completely invisible to any observer. But those tiny fluctuations I mentioned? They were setting the stage for everything that would come next. These microscopic variations in density were like seeds that would eventually grow into the largest structures in the universe. The slightly denser regions would attract more matter through gravity, eventually forming the first stars, galaxies, and galaxy clusters. The confusing part is that we can't directly observe this period. It's like trying to understand a movie by only watching the first and last scenes. We can see the cosmic microwave background, which shows us the universe at the moment of recombination, and we can see the universe today, but those 300,000 years in between remain largely mysterious. Scientists have some incredible theories about what was happening during this time. Some suggest that dark matter, which makes up about 27% of the universe, was already beginning to clump together and form the invisible scaffolding that would guide the formation of visible matter. Others propose that exotic particles we haven't discovered yet were playing crucial roles in shaping the cosmos. What's even more mind-bending is that during this period, the universe was expanding so rapidly that regions of space were being stretched apart faster than light could travel between them. This means that different parts of the universe were completely cut off from each other, unable to exchange information or energy. Yet somehow, when we look at the cosmic microwave background today, we see that these disconnected regions all had nearly identical temperatures and properties. This is known as the horizon problem, and it's one of the biggest puzzles in cosmology. How did separate regions of the universe, with no way to communicate with each other, end up looking so similar? The most popular explanation involves something called cosmic inflation, a period of exponential expansion that happened in the first fraction of a second after the Big Bang. But here's what really keeps astrophysicists up at night. Recent observations from advanced telescopes have revealed structures in the early universe that are so large and so organized that they shouldn't have had enough time to form. We're seeing galaxies and galaxy clusters that appear to be billions of years old in regions of space where the universe itself was supposedly much younger. This has led some scientists to question our fundamental understanding of how the universe evolved during those mysterious 300,000 years. Maybe the Dark Ages weren't as simple as we thought. Maybe there were processes happening that we haven't even considered yet. As we continue to develop more powerful telescopes and detection methods, we're slowly beginning to peek behind the cosmic curtain. Projects like the James Webb Space Telescope are pushing the boundaries of how far back in time we can see, potentially giving us glimpses of the universe when it was less than 1 billion years old. The most confusing moment in the universe might have been those dark ages, but they're also the key to understanding everything that came after. Every star you see in the night sky, every planet orbiting those stars, and every atom in your body can trace its story back to those mysterious 300,000 years when the universe was figuring out how to become transparent. So the next time you look up at the stars, remember that you're seeing the result of the universe's most confusing period, when everything we know today was just beginning to take shape in the cosmic darkness.